This is the Math Counts Homework for September the 9th. We have a few problems this time. Most of it is review. All right, number one, we have an old math trick. So remember that this is not the standard way of doing multiplication. This is just a shortcut, and the shortcut only applies when you have a tens place that are the same. And because this one is a 1, it's even shorter. In problem number 8, you'll see the full problem. All right, 17 times 18. Most kids write like this, 17 and 18. And when we are entering high school, we do a times, like a dot instead of an X, because we were dealing with variables in high school, and we don't want to forget that this is a times. Is it a variable? What is it? Is it a letter? We can't tell. So usually the way we do this is we say 17 plus 8. Let me do it in a different color so it really pops, right? 17 plus 8. That's going to be 25. And then we just slap on a 0 or multiply by 10, whatever you prefer. And then lastly, we add a single number, and then we'll be done. The single number that we add is 7 times 8 for 56. Adding these together, we say 0 plus 6 is 6. 5 plus 5 is 10. Carried the 1, so 10. And then we say 1 plus 2 is 3, so the final answer is 306. What about number 2? Number 2 is another trick. Whenever you multiply by 11s, you could do the following. You can say that is going to be 6 and 3. And this only applies to multiplying by 11. You separate all the digits, and then you add the two numbers to the middle. 6 plus 3 is 9, so 693 is your final answer. Let me show you a harder, much longer example that I wish I could have included in the homework. I didn't think of it until just now. What if I did 11 times a different number where you have to carry it? What if I did 7, 8, 1, 2? So watch how I do this one. You separate all the numbers. 7, 8, 1, 2. And then there's a space in between each of them. In the last one, you had to do 1 plus 2 to get 3, and that still does work in this case. Let me do those on a different color. And then you'll do 1 plus 8 to get 9. But here's the kicker. Sometimes you do something that's bigger. 8 and 7 add up to 15, but you do not write 15 because that would be two numbers in the spot where you're supposed to have one number. Whenever you have a number that's 10 or larger, you have to carry the 1 to the next place. And the way you really write this is 15 like this, and then you have to add the 1 and the 7 to get your final answer, which is going to be 8, 5, 8, 9, 1, 3, 2. Put some commas in there so we can say that's 8,589,132. You didn't have to do that one, but I just wanted to show you a better example. All right, most of today was spent on doing orders of operations, and this is one of those cases. So to remember your order of operations, we have PEMDAS. We can say it's please excuse my dear Aunt Sally. And remember what these are standing for. P is for parentheses. E is for exponent, also known as power, but we don't write a double P, so we say exponent. Multiplication and division, addition and subtraction. And notice the way that I've written this thing. I've written it in a peculiar way. Old school mathematicians might have written PEMDAS like this. Please excuse my dear Aunt Sally. This implies that you have to do multiplication before division and you have to do addition before subtraction, which is incorrect in terms of how mathematics is performed. Multiplication and division are on the same level of importance. Whenever you see multiplication and division at the same time, you just do whatever is on the left. Sometimes division's on the left, sometimes multiplication's on the left, you do whatever's on the left. Same thing with addition and subtraction. If you only have addition and subtraction, do whatever's on the left first. Go left to right, the way that you read. If you don't do it left to right, you will be making mistakes. And notice on this case, I purposely put the division in front of the multiplication because some people think, oh, you have to do multiplication and then division. That's incorrect. So let's go ahead and do this one. So first, I'm going to see the 12 divided by 4. I'm jumping ahead of myself. I first look for parentheses. There are no parentheses. I look for exponents. There are no exponents. And then I look for multiplication and division. This is not multiplication and division, but this one is, so that's the one I choose first. 12 divided by 4 is 3. Ooh, I went to write that in pen. It's 3. And then I have to rewrite 8 plus 3 and then times 2. From there, I'm going to look again for any multiplication or division. Oh, look, right here, that dot again means multiply. We don't write x's anymore. We're getting ready for high school, getting ready for the upper level math. 3 times 2 is 6, so I can say you turn into a 6, and then I have 6 plus 8 to get 14. And I guess I can go ahead and highlight it for consistency. 14 is my final answer. We definitely box our final answers. Let's try a much, much harder one. So again, we're doing PEMDAS. Let me go ahead and rewrite my checklist. Please excuse my dear Aunt Sally. I didn't check those off. That feels inconsistent. Okay. Are there any parentheses in this one? No. done. Exponents, no, done. Okay, I'm looking for any multiplication or division. Oh, look, I see some multiplication and division right there. You always start on the leftmost problem. So 8 divided by 2 is 4, and then I rewrite the rest of the problem. You don't need to rewrite the rest of the problem. Let me show you something that would be like incorrect. Not necessarily incorrect, hard to read better. If you said 8 divided by 2 is 4, and then you said, okay, the next thing is, oh, then this 4 and 3 that turns into a 12. You could see how messy this looks. Yes, you can do it. And when you're in a math counts competition, maybe it is more beneficial to do it because it's faster. For the sake of this video, I just want you to understand. So I'm going to go step by step, nice and slow, so that everyone understands the work. You do not need to show all of this work for your homework assignment. You can go ahead and shorten the work. For example, maybe another better way would be down here and say 4 times 3 is 12. I'm going to write it line by line so you can see exactly what's going on in my noggin. So I'm going to rewrite the problem. 4 plus that number times 3 minus 5 plus 6 divided by 3 times 4 minus 7 plus 9 divided by 3. Is there more? Here, let me write them exactly underneath so they don't move, right? 9 divided by 3. And I need to be careful because I have a feeling I'm going to run out of room. Let's keep that really nice and tight up here. Okay, next, I'm looking for any multiplication and division. And oh, look at that. We have 4 times 3, which is just 12. And then I rewrite the rest of the problem. Plus 4 minus 5 plus 6 divided by 3 times 4 minus 7 plus 9 divided by 3. Next, what do we see? I see some more division happening over here. So I'm going to rewrite that. 6 divided by 3 is 2. So I'm going to say plus 5. There's a 4 there, plus 12 minus that 5. Then I have a times 4 minus 7 plus 9 divided by 3. Okay, what do we see next? Addition, subtraction, addition. Okay, multiplication comes next. So I'm going to say these go next. We're going to say 2 times 4 is 8. And I'm going to rewrite the problem. It's going to be 4 plus 12 minus 5 plus this 8 minus 7 plus 9 divided by 3. What do we see next? Any multiplication division? Oh, there's the last one. So let's go ahead and highlight that one. We're going to say 9 divided by 3 is 3 and rewrite the rest of the problem. 4 plus 12 minus 5 plus 8 minus 7. And then the plus sign has to be remaining. Plus a 3. Okay, notice on our checklist, we are now done with multiplication and division. We're on to addition and subtraction. And we are going to start on the far left. Notice that everything is in this rung. So I'm just going to go, whatever's on the far left is going to be done. So 4 plus 12 is 16. I'm going to say 16. I'm going to write this a little bit nicer. 16. That wasn't much nicer, was it? 16 minus 5 plus 8 minus 7 plus 3. And then I do whatever's on the left. 16 minus 5 in this case is 11. Plus 8 minus 7 plus 3. 11 plus 8 is next. You turn into a 19 minus 7 plus 3. And then we do 19 minus 7, which is 12. 12 plus 3, and 12 plus 3 is 15. I do want to have highlighting for my final step, and I eventually do get 15. I might have made a mistake. There's a lot of math. I tend to make mistakes. I am human. I learn and I grow from them, just as you learn and grow from your mistakes. That's the growth mindset. All right, number 5. This one is notoriously difficult, especially for students that have not seen this type of problem before, or maybe it's only your 5th rep. Here's how you think about this problem. And we don't have very much room here, so I'm going to write on the top of this and kind of borrow some of the space up above, right up here. Okay. The way that we think about this is we think 5 plus, and let me do this really big, 5 plus 51 is 56. 6 plus 50 is also 56. 7 plus 49 is also 56. You get the pattern, right? All of these pairs add up to 56. And then you can see the next question is like, if we know how many pairs of 56 we have, then we just multiply the number of pairs that we have by 56, and we'll get our final answer. That is the quick way to do this. However, I made the problem really difficult because I don't know how many pairs there are. But in general, if you want to find a sum of a large number, and by the way, there's this ... here, there's 9, 10, 11, 12, all of the numbers are in there. I'm just too lazy, so I did ... All of those numbers are there, I just didn't want to write them all out. So to do this problem, we need to have the basic formula that says this. To get the sum, to add up all these numbers, the way that we're going to do that is we're going to take the number of pairs, and we're going to take that, we're going to multiply it by this number 56. That 56 came from doing the first plus the last. And I do cursive L's for most of my first words, just because sometimes you think it's a 1. That's our guide. That's how we're going to do this problem. So we need to figure out the number of pairs. That's the hard part of this. We already have the first plus the last. Well, let's go ahead and write that one in. Pencil it in and say this is times 56. The hard part is, what is the number of pairs? So you have to have the number of numbers first. So if I could count all of these numbers, I'm missing some, so it's kind of hard to count. But if I could count the number of numbers and then just divide it by 2, that would be the number of pairs, because if there's all of these, that 2 turn into a pair, that 2 turn into a pair, that 2 turn into a pair, I basically have to count the number of numbers and then divide by 2. A lot of students will be tempted to just do the last number minus the first number. And you're really, really close. I'll show you why that's not correct. I'm going to go ahead and erase this example, so go ahead and just don't write this. If you do the numbers 1, 2, and 3, and I just do the last number minus the first number, you get 2. But there's clearly 3 numbers here. So the way that you actually count numbers is you do the last number minus the first number, and then you just randomly add 1. You always just randomly add 1 at the very end. I guess it's not that random. It's just a formula that you have to know. And it's because you don't want to count one, or you accidentally discounted that number. So we always do last minus the first, and then you just add 1. So in our case, to find the number of pairs, I'm just going to find the number of numbers in this case. It's going to be 50, and let me do this in blue so that we have consistency, 51, and then I'm going to subtract 5, and then I have to randomly, I say randomly, but you do have to add that 1. That adding 1 makes it that we actually have all of them. All right, so what is this, right? 51 minus 5 is 46. 46, so I'll show my work like this. That turned into a 46, and I still have to do plus 1. And 46 plus 1 is 47. I don't know how to write a 4, apparently. 47. Oh, my goodness, it's late. 47. Cool, but that isn't the number of pairs. This is the number of numbers. I told you to find the number of pairs, we take the number of numbers, and then we're going to divide that by 2. So really what I have here is a bunch of scratch work that needs to go and be somewhere else. This is the, and I'll label this. This is the number, I'll say this is the quantity. This is the quantity. And to get the number of pairs, it's to get this thing, we're going to do quantity divided by 2. So here I go. Quantity is 47, and then I divide it by 2. This is the number of pairs. And I know what you're thinking. You probably didn't watch the last video, and you're thinking, that's not an even number. You can't get a whole number out of this. There's like a decimal. There's like a 0.5. That's 23 and a half pairs. You can't have 23 and a half pairs. I mean, you're kind of right, but let me show you something that's interesting. If I do the numbers 1, 2, 3, 4, and 5, and I do the pairing method, 1 plus 5 is, maybe I should have done a plus in between here instead of commas, huh? Let's do plus, so it's a sum, just like the problem that I have up here. If you do 1 plus 5, you get 6, and 2 plus 4, you get 6. And you say, how many pairs were there in here? You think there's 2 pairs with 1 left over. That leftover will always, always, always be half of that pair. It's just the mathematical principle. So you can technically have half of a pair. It's just the middle number, which is half of the total sum. So it's okay to have a decimal here. Let me go ahead and erase it. That was just for sake of demonstration. So now we have this problem, which is kind of hard to do, right? I don't know how to do 47 divided by 2 really well, and multiplying by 56 is making it even harder. So here's a cool thing when you have all multiplication and division. Since we're on the same rung of PEMDAS, we're on this rung of multiplication and division, it doesn't matter which one you do first. You're supposed to do left to right, but whenever you have a fraction, something cool happens. You can extend that fraction. Maybe we should talk about why. Okay, here's why. This is technically 56 over 1. Any number is divided by 1. And when you multiply fractions, you multiply the tops, you multiply the bottoms. If I multiply the tops, this is really turning into, new color here, 47 times 56. And 56, my numbers are not numbering. 56 on the top. And the bottom, 2 times 1 is just 2. So it's essentially like extending that line, basically, right? That's what I've done over here. So I can choose, do I want to do 47 times 56 first? Or do I want to do 47 divided by 2 first? Or do I want to do 56 divided by 2 first? You're allowed to choose. I'm going to choose to do 56 divided by 2 first, because that is a problem that is easier to solve. And I can solve it in my head right now. Yeah, 28. How do I do that, though? Let me show you what's going on in my brain that's going at rapid fire, because I have a ton of repetitions of this. I practiced this a lot. So I'm going to do this problem right over here. How do I do 56 divided by 2? That's the question. Well, 56 divided by 2 is hard to do. So I'm going to think it's really close to 60 divided by 2. And that's easier because 6 divided by 2 is 3. And then you slap on a 0, and 60 divided by 2 is then 30. But that's cheating. 56 is not 60. So I need to modify this a little bit. I'm going to go ahead and extend this line and say, okay, in order to get from 60 to 56, I'm going to subtract a little bit. I'm going to subtract 4. And if I do that, then this turns into a new problem. This is turning into 60 divided by 2 minus 4 divided by 2. You're allowed to break up your fraction, cut it right in half, as long as both of them are still divided by 2. When we talk more about combining like terms, or not combining like terms, but combining fractions with like denominators, this is kind of like going backwards, but you are allowed to do this. And I can talk about that more at length later. I just don't want this video to be too long. It's already very long. All right, so 60 divided by 2, done, 30. And then I have to subtract 4 divided by 2, which is minus 2, and we get 28. So the correct way of doing 56 divided by 2, this is how you do it in your head. Again, this is a lot of work. I don't expect you to show that all out on paper. I expect you to think like this. This is the faster way to think. So what have I done? 56 divided by 2, I can go ahead and show my work and say, well, this number turns into a 28, which means I now have 47 times 28. And then I'm done. So here's my new problem. I'm going to say 47 times 28, and then that's my final answer. Unfortunately, I don't know of any trick to do this. I know like a kind of trick, but let's practice our standard algorithm because we should be really fast at that standard algorithm. So we're going to say 7 times 8, that's 56. So you say 50, oh, I don't write the 5 there, I write the 5. I have to carry it, right? So 56, see, I need to practice standard algorithm too. 8 times 4 is 32, plus 5 is 37. Okay, now I'm multiplying the tens place, so that means I have to have a 0 because I'm in the tens place. And then 2 times 7 is 14. I carried the 1. And then I'm going to say 2 times 4 is 8, plus 1 is 9. And I get 940. I think I did that right. And then from there, I'm going to add. So adding together is going to give us a 6 here. 7 plus 4 is 11, so it's 1, 1. And then 1 plus 9 is 10, plus a 3 is 13, so 13,000 or 1,316 for my final answer. All right, moving on to number 6. The name of a shape with 7 sides. We did get to talk about this one in class. There's actually 2 names that you can use. You can either say it's a heptagon, or you can say it's a septagon. Septagon. This one is more preferred. This one gets the star by it. Really, both of them are correct. You can't be wrong. This is the one that students will be seeing in MathCounts more often. I've never seen that one in any MathCounts textbook, but I'm still new to this. Here's why people typically prefer heptagon. This is actually for a good reason. It's because you have hepta, which is Greek for 7. And then you have gon for gonia. So it's like heptagonia, right? Gon is also Greek. You're combining a Greek, 2 Greek roots. However, with septagon, this is combining the word septum, which is Latin, with gonia, which is Greek. It's really awkward to mix Latin and Greek, but we do it all the time. So that's why it's still acceptable. Just to give you an example of how often we mix different roots like Latin and Greek, we're not supposed to. We like consistency in English, but sometimes we don't have consistency. To give you an example, did you know that triangle, I'm just giving you random facts now, triangle, making you smarter. Triangle is also a mix of Latin and Greek. So you have tri, which is Latin, and angle, which is Greek. So again, that one doesn't make sense. If we wanted to be pure Greek, then we would say trigon, but it didn't catch on. I don't know. It wasn't popular enough. Same thing for whenever you have a 4-sided shape. We call that a square, but it's really called a quadrilateral. So let me look at quadrilateral. The triangle is 3, quadrilateral has 4. The word quad or quadri, I guess, is also Latin. This is Latin, and lattice is actually Latin as well, isn't it? Yeah, so I guess it's Latin and Latin. So I guess that one makes sense, but we try to keep everything Greek. Other things that are kind of weird, if we wanted to call a 4-sided thing Greek in Greek, we'd call it a tetragon, which I think is way cooler, but whatever. We don't say it. A pentagon is Greek in Greek. Hexagon is Greek in Greek. We have Octagon is Greek and Greek. We have, okay, then we get this next one, right? Let's talk about 9. How do you do 9 sides? So with 9 sides, you have 2 words. The one that we talked about in class is the one that everyone says. It's nonagon. Nonagon is way more common, but again, you're mixing your Latin with your Greek, which is not cool. So you have nonus, which is Latin for 9, and then you have gonia, which is Greek. You're mixing your Latin and your Greek, but again, everyone does it. And it's actually kind of for a funnier reason, because the correct word that no one uses is enneagon. Enneagon, which again, this one is Greek with Greek. Greek with Greek. I think a lot of scholars believe that the reason we didn't say enneagon is because it sounds like an enema, or I don't know, like we were getting it confused. It's a lot harder to spell, a lot harder to say, and people are mixing it up. So, and nonagon also entered the English language much earlier, around like the 16th century. Yeah, so cool little facts there. We should probably keep going to the 10-sided one. It's called a decagon, which is Greek and Greek. So good job for the decagon. But again, it's kind of weird that we have all these weird things in English, right? And I am a math teacher, so I know quite a bit about the math, right? You know some other weird things. We say 11. Isn't 11 a weird word? Because most European languages will say like 15, they'll say like 5-teen, right? 16. That all makes sense. So why don't we say 1-teen, 2-teen, 3-teen? We should say that, but we kept those old oddball Germanic forms. I think it was like Endleophon, or I don't know how to pronounce German. Mr. Warner can get in here and correct me, but we kept it with German for the first few words after 10. I don't know why we did it. Inconsistent, but there's a lot of inconsistencies in English. We just do whatever comes first and whatever feels best, I think. So number 8, this is very similar to problem number 1, except it has the full process. So again, you could do it with a standard procedure and it would take a long time, but my new procedure is faster and you can do it in your head, which is why we're learning it. We can only do this when the tens digits are the same. So it's a very rare case that we can use this. And the way that we do it, let me go ahead and write it again. It's 34 times 38. We do this, right? We add the 34 and we add the 8. We get 42. Normally, we'd put a 0 here by multiplying by 10. We don't do that now. Instead, we multiply by whatever the tens digit was, which in this case is 3. And I'm hoping you're asking, well, why didn't we do that before? We actually did. Because right here, before I had all of this work, when I just had 25, let's do 25 times the tens place. Oh yeah, we're multiplying by 1, so I just skipped that step. Technically, we did have to multiply by the 1, and then we added the 0, or multiply by 10, put the 0 there, and then we added the 56. But we got to skip a step because of the 1. Whenever you don't have a 1, you have to do the whole thing. You say times 3, and then you do the standard procedure. You say, okay, 3 times 2 is 6. And then you say 3 times 4 is 12. Okay, now you can keep on with the old procedure. You slap on that 0 by multiplying by 10, and then you add these last 2 digits multiplied. 4 times 8 is 32, and you can say plus 32, and you get 1, 2, 9 to the end. You get the right answer. So now you know the full procedure. We did a ton of review. Let me zoom out. Wow, look at all that math we did. Good job, guys. One final thing before I leave. A lot of students were asking about the video game that we were playing in class, and I know that parents at home are probably wondering too. So if you're a parent, this part is mainly for you. How do you get your kid to play video games and learn math? Because by the time they hit high school, a lot of kids start playing video games and they do less academics. So if you go to a web browser, I'm just using Safari in this case, if you search for Mr. Sindel, you can go to my website. That second link that says Mr. Sindel works, although the first one still works as well. And the third one is my YouTube channel. Oh, wow, I'm famous. All right, the second one, I'm going to click on Mr. Sindel, and it goes to my website. If you click on the top left where it says Mr. Sindel to the left of integrated 1, you'll see all these drop downs. The one that you want is Bluekit. If you click on Bluekit, it comes up here. This first section is for you guys that are all in math counts. And then eventually you get into like the higher levels, like algebra 1, and you do a bunch of harder things. But this is for us. We should have all these down. So if you don't have your multiplication numbers 1 through 10 down, you should start there. But there's some other ones like multiplication 2 through 12 that's slightly harder. The one that I love the most is the one that's on the top right of my screen right now, the multiply and divide Oh, wait, not that one. Where's the one that I love the most? Okay, now it's in the top middle of my screen. Operations with negative integers. You have to add, subtract, multiply, and divide. The numbers are small. I only use numbers 1 through 5, and they're all positive and negative. It's really tricky because negatives really confuse students. So that's the one, if you have some free time, go learn how to do those. But for the sake of demonstration, you're learning your times tables. You can click on this top left, multiplication 1 through 10. It will open up Blue-Kit. Normally, you will be signed out. So let me go ahead and log out and pretend, oh, okay, I clicked here. Let me click on this one again, multiplication 1 through 10. Oh no, I'm not signed in. It's not letting me play solo. If I look to the left of assign homework or beneath host game over here in the kind of middle-ish of the screen, it won't let me click on play solo because I have to log in or sign up. So you have to log in, unfortunately. Luckily, I have a Google account associated with this. So I can just click on my Google account and sign in. You do somehow have to sign in. I am sorry, but it's the way that Blue-Kit works. Once you're signed in, you can see that this play solo button is now a purple color instead of the grayed out non-color. If you click on play solo, you can choose all of these different game modes. If you just don't like playing games, you can come down here to the very bottom and just study and grind away like crazy and get even more reps in. But that's hard for even me to do. The one that most students were playing today was Tower Defense 2. It's a little bit better than normal tower defense. The other really popular one in my class is Monster Brawl. Those are the two most popular. Pirate Pool is pretty fun too. It uses a little bit more geometry. I have found in my experience that it's a lot more playing video games than it is doing math, whereas Tower Defense 2 is a lot more math than playing video games. So that's why I prefer this one. I'm going to go ahead and play it and show you how this game works. So I'm going to click on New Game. You can replace empty round. So round 4, I'm going to go ahead and replace that one. Choose whatever game map you want. I'm just going to do Sunny Meadow. It's nice and easy. How hard do you want it? I'm going to just do easy. And you can see how this game works. So I'm not going to do the tutorial. I am the tutorial. So you have to get 3 problems correct. So you have to say 4 times 10 is 40. Ooh, cute little noise. 10 times 5 is 50. And okay, let's pretend you get one wrong. If you get one wrong, I know that's 63, but like, I say it's 72. It says you have to wait, you have to learn. Okay, it was 63. You are forced to learn. Click anywhere to continue. Once you get your 3rd one correct, then you get to play the game. So you get to put towers wherever you want. I'm going to click on the dragon. It says, where do you want to place the dragon? I'm going to put it right at the entrance to kill them as soon as they come out of that entrance. And then the exit is in that top right. So I'm going to hit start in the bottom right. And the dragon is killing these enemies as they come in. I'm going to hit ×2 speed so it goes faster so I can go through this video. Let's try it again. Okay, so 3 more questions correct. Let's see how fast Mr. Sindel can go through these as I talk, right? So once you level up, you can get some more coins. I'm going to put an owl like right in the center. I love owls. I think that they're OP. They're overpowered. Go ahead and hit start. It's still in ×2 speed. I can slow down to ×1 speed. And you're just kind of grinding away over and over, playing a video game every now and then to kind of lighten the mood. And I don't know, it's kind of fun. You just keep adding on to your tower defense, and you keep playing this game until you lose. Eventually, the mobs will break through. Maybe you're such an excellent player that they'll never break through, but I think it's a great mode. There's a bunch of different fun game modes. And if you don't like all the game modes that Blue-Kit has to offer, then I can show you the Gim Kit that you can place down. Gim Kit also has a bunch of other games, and it's the same exact type of math. All right, well, that's my pedestal. Thanks for watching, guys, and I'll see you guys at the next Math Counts practice.